Hello, class. This is the start of chapter 9, which is hypothesis testing. And so this is based on this concept of a confidence interval that we talked about in the last chapter. And now we're going to make some assumptions and run some statistical analysis to see if our assumptions are true or false. And we don't know for sure. Again, remember, we're talking about ideas of confidence, and we're never going to have 100% confidence that statistically we're right or wrong. And so you do have to remember that. But the higher our confidence level, the lower our error rate will be, et cetera. And so we'll have a good feeling that things are going to be either true or false. So in this section, and the book does a really good job in the first section of chapter 9. So I'm going to follow its lead quite a bit. And we're not going to do any analysis in this. We're just talking about definitions and kind of getting things set up. And so the first thing we're going to define is this idea of what our hypotheses are. The hypotheses are set up into two categories. The first one is called the null hypothesis, and the second one's called the alternative. And the idea is that we set these two up depending on what we're trying to prove. And there is a very mathematical way that we set these up. And the way that we set these up is, here's an example where we have this Journal of Air and Waste Management has an old engine that has what they call particle matter of 35 milligrams per mile of travel. And they want to see how this new engine performs. And so the way that we set this up is the mean is from the old, or what you're assuming. So here, the null hypothesis will always be equal to the mean. And so in this case, or equal to the value that we're dealing with, this would be 35 milligrams. And so the idea is, what is our alternative hypothesis? Well, our alternative hypothesis is what we want to actually happen, what we're trying to prove that is true. So in this case, it should be less than, right? Because you hope you make an engine that's more efficient and less pollutant, and it would be less than in this case. But when you set up these hypotheses, the null hypothesis is quite nice because that's going to be equals. But what do we do with the alternative? Well, it just depends on what we're trying to prove, right? And we have three different possibilities: less than the mean, greater than the mean, or not equal to the mean. And that's set up like we have in our confidence intervals, right? If this is our mean, and we have a confidence interval that looks like that, and doesn't matter, some sort of percentage, I'll just call that our confidence level. And so this is what we call our tails, right? Well, guess what? This is called the right tail, and this is called the left tail. And these are the percentages or probabilities that we are going to be calculating when we do the hypothesis testing. And so the idea of the right tail would be the greater than, the left tail would be the less than, and the two tail is when you add both those together. So it'd be the LT plus the right tail. And so that would be mu not equal to the mean. And so you'll see when we walk through this analysis, these are the types of calculations we're going to be doing actually with numbers associated with it. So let's walk through a couple examples on just the setup. And so here's an example of the serial one where we say a mean of 20 ounces in each box, and the inspector thinks that that's wrong and actually expects that it's less than, which would not be good, right? And so you see how the null hypothesis is set up as equals, and the alternative is set up as less than. So that would be the left tail test. This example gives us where we have a real estate agent of rent of apartment in a city is 800, and they think it's higher. So again, equals is the mean, which is the null, and now this would be a right tail test because it's greater than. And then if you have a situation where you're not sure, right? Where here we have a mean of 70 on this standardized test, and the educator believes that the mean has changed, but it doesn't indicate that is it gone up or is it gone down? It's just not the same. And so in this case, that would be a two-tailed test. So that's kind of, you have to kind of read the problem and kind of deduce what kind of alternative hypothesis that you have to set up. Where'd my mouse go? There it is. Sorry about that pause. I find that this is a really good analogy. Kudos to the book on this one. So the idea of the hypothesis testing, it's very, very similar to criminal trial, is that when you set up this testing, the idea is that you are innocent until proven guilty. So the hypothesis test is set up where you actually want to get a guilty verdict, which would mean in the testing that we reject the null hypothesis, which would mean that the alternative hypothesis is true. And when you set up this testing in this particular class here, where that is going to be our ultimate goal, is that you hope that the null hypothesis is false and you can reject it. And so when you do that, it kind of follows this idea, is that you assume the hypothesis is true, and then you run this test. And if the test tells you that it's not, then you reject it. And we'll show you how to do the test moving forward. And so that's the ultimate goal. So this is important though, but you either reject, but you don't accept if the test doesn't give you the rejection conclusion that you're hoping for. It's that you fail to reject, or sometimes I've seen some books say do not reject. So that doesn't mean that it is true, and it doesn't mean the alternative hypothesis is false. It means that the test that you ran gives you an inconclusive result, which is different. And so what you would want to do is get more data, right, to be able to run the test again if you're really trying to prove that the null hypothesis is actually false. So again, the conclusion is going to be one or two-fold. Reject the null hypothesis, which implies the alternative hypothesis is true, or you do not reject and you know nothing, really. And basically, that's an inconclusive test. That's the best way I kind of like to think about it. And so the other thing that we talk about in this case is type 1s and type 2 errors. So what we mean by that is the following, and this table is very useful. So you'll be able to walk through a couple of these in the homework. And the idea is that a type 1 error is where you actually reject the null hypothesis when you shouldn't have. And so it says here that we reject HO. The type 1 error is it's actually true, which means you should not reject, right? And the correct decision would be do not reject. And then type 2 error is when HO is actually rejected. In this case, that would be the correct decision here if HO is true and you fail to reject, fail to reject. But if it's actually false and you fail to reject, that's called a type 2 error. And so I always have to go back to the table to try to figure this out. Let me show you one example. And so here's one here, where here, dean of a business school wants to determine whether the mean of the starting graduate students is greater than 50,000. And so you set null to equal 50 and the alternative to greater than. And suppose the true mean is 50. and the dean rejects HO. So let's go back here. So the true mean is 50, so HO is true, but he actually rejects, right? So there is a type 1 error. That's what, so if you reject and it's true, it's always type 1. So always have to go back to that table. So the table's on slide 18, and you'll find it in the book as well. But I think what's more important is not only to recognize what kind of errors they are, but you need, when you run these tests, to make sure that what is the error that is the most critical of the error. And usually one of them is more critical than the others. And these are kind of fun examples that I took out of a different book. So suppose that the null hypothesis is Frank's rock climbing equipment is safe. So a type 1 error would be Frank thinks his rock climbing equipment may not be safe when it actually is safe. So that's a type 1 error, right? The idea is that he thinks that it may not be safe when it actually is. So if you go back to here, the type 1 errors he rejects, right? But it actually, the correct decision that it's actually true, right? And so if you look at that, at least that's not going to hurt people, right? Because the type 2 error here, you can see, is much worse. That Frank thinks his rock climbing equipment may be safe. In fact, it's not safe. And so would you want to use not safe rock climbing equipment? So you can see that the type 2 error here is much worse than the type 1 error. And this one gave me a giggle in the previous book that I taught out of. Is suppose the null hypothesis is the victim of an automobile accident is alive when they arrive at the emergency room of the hospital. So here's a type 1 error, right? Which would be really bad. The emergency crew thinks the victim is dead when in fact he's alive, right? Obviously kind of giggle. Hopefully when I read that, I did too. And you can see at least the type 2 error is that the victim is alive when actually is dead, but at least they're trying to save somebody, right? So you can see here the type 1 error is much worse than the type 2. And why I like to bring those examples up is that you have to think about what you're trying to do, especially for me as an engineer. There are certain things that are more critical to get right than other things. And I always go back to the bridge example. It is very critical to make sure that your bridge doesn't fall down. So you want to make sure that that error does not happen, right? And so the idea is that sometimes some errors are less critical than others. It really is important in a lot of real world applications. So that ends the recorded lectures for section 9.1, which is the introduction of our terms for hypothesis testing.